Here we are with our Math 1 Term 2 project. So, once again, treat this like a take-home test, a way to kind of show what you know about the sequences we've been learning and about the systems we've been learning. So, you take a look at the back of the page, you pick one of these pairs of sequences. Okay? So, in this example, I'm not going to use that pair, I'm going to make up my own. You have to use one of these. So, if it ends up that when we correct your paper, you have my sequence over here that I'm going to write, well, then you get a straight up 0, because all you did was copy me, which is not cool. Okay? So, pick your own. Doesn't matter which one you pick. Okay, they're all going to be about the same amount of work. So, here's the sequence that I'm going to go over. Sequence A, 2, 3, 4, 5. My sequence B, 14, 12, 10, 8. So once again, these are mine, not yours. Yours are over here. But you're going to be doing the same process, okay? It's the same process. So, if I look at sequence A, I've got 2, 3, 4, 5. So first thing, make a table. So, and then I'm going to label it. So I can label it X and Y. I can label it X, F of X, which is what I'm going to do. Okay? You could also label it X or Y, or even any other variable you wanted to, or even something entirely different. So, that's what I'm going to put mine as. So now, with my X, this right here is going to be my first term. So this would actually be 1, 2, 3, 4 right here. So that would be 2 my first term, my second term, my fourth term, and my fifth term. Okay. Now, I intentionally left that top part blank because for my explicit formula, I want to know what the 0 term is. Okay. This sequence doesn't give me the 0 term, so I've got to figure out the pattern. Well, what am I doing? I'm adding 1. As I add 1 to the left, I add 1 to the right. So going backwards, I would subtract 1 and end up with 1. Okay. So for my recursive formula, I need that starting point. So I'd go f of 0 equals 1. Okay. Then, for my second part, I say, okay, to find my next term, f of x, say I wanted to know what the fifth term was. What do I need in the recursive? Well, in order to find this in the recursive, I need that one. So I'm saying if x were 5, I would need 4, which is x minus 1. 5 minus 1 is 4. So my previous term, I write f of x minus 1. And then what's our pattern? We're adding 1, so I add 1 to it. There's my recursive formula. Okay? Easy to make, not very useful. Okay? And remember, it connects output to the next output. Okay? We want the explicit formula. That's the one that's going to be easier to use. Okay? In everything that we're going to have to do after we get these formulas. So, and that connects the input to the output. Okay? The x to the f of x. So I go f of x. You could also write y equals, same thing. And then I say, well, where did we start? Well, at that 0 term we started. So at 1. What did we do to 1? Well, we added 1. How many times are we going to keep adding 1? Well, we're going to keep adding 1 as many times as possible, right? And the cool thing about this is if I added 1 4 times, okay, that would get me to that number. We'd take our starting number of 1 and then we'd go 1, 2, 3, 4. We'd add 1 4 times. So an x goes next to that. Now I can rearrange it and make it 1x plus 1. I could even say just x plus 1 or f of x plus 1. f of x equals x plus 1. Any of those would work. This one's probably the one you're most familiar with, or even that one. So I would choose either one of those. With graphing, you guys typically like the y equals better. But any one of those styles of equations would work. Okay? So there we go. That's the first sequence. Now let's take a look at our second one. So once again, I'm going to go x and f of x. And don't pay attention to this yet. That's just part of the graph, but it got cut off. So we've got our 0, 1, 2, 3, 4. Remember, this is our first term, not our 0 term. So that would be 14, 12, 10, and 8. So we are subtracting 2 each time, aren't we? So what number minus 2 would give us 14? Well, we go backwards, it would be 16. So for our recursive, we go f of 0 again, same format, equals 16. And then we say, okay, if I wanted to get to that next term, if my f of x were 5, we take that previous term, so x minus 1, or 5 minus 1, which would give us 4, which is 8, and then what did we do to it? We subtracted 2. So there's our recursive formula. So to write the explicit, I go f of x equals, okay, we start at 16, right? We start at the 0, and we're subtracting 2 each time. So 16 minus 2, x, which once again I can rewrite as y equals negative 2x plus 16, or as f of x equals negative 2x plus 16. Alright, so the next part says it wants us to graph both sequences, A and B, on the pair of axes to the right. So, two ways I can do that. I can use the equations I created, the explicit, or I can use the table. Either one will give me the same answer. Okay, so I'm going to write, let's see, so B was y equals negative 2x plus 16, and I'm going to write it in that slope-intercept form, x plus 1. And A was y equals x plus 1. So we've got our y-intercept of 1 for my first, and then a slope of just x, so that's like 1 over 1, right? So up 1 to the right 1. So I'm going to go like this. I'm going to graph it as far as I need to. And this is a really big graph, so it's always a good idea to graph as much as possible, which on this big graph means I'm graphing a lot here, aren't I? And I can trace my line as best as I can. There's my first one. That's A, right? May want to label them. Then B, we start at 16, so clear up at the top. And now my slope is negative 2 over 1. So I'm going to go down 2 to the right 1. And actually that's 15, isn't it? So my graph would be slightly above that. So I'd go down 2 to the right 1. So it'd be like clear there. Kind of off the screen barely. Down 2 to the right 1. Which should be matching up with my points on my table, right? Because you could have continued your table and found where they intersect that way as well. Down 2 to the right 1. Okay, so there's our graph. And we can see where they intersect, right? Right at this point, which is 5 for the x value, 6 for the y value. So 5, 6, so that's what I write out here. 5, 6. So now you could have just continued your table, and had I, continued mine, we would have figured that out right here. And that's a great way you can use a table to help it out as well. But there we go. There's where they intersect. So we know that that's the intersection point. But now they want us to solve it using the substitution method and the elimination method. So let's take our same equations. So y equals x plus 1 and y equals negative 2x plus 16. So substitution, remember, you get one of these variables by itself and say these two are the same. So I can substitute that in for this other variable. So instead of y, I'm writing negative 2x plus 16 equals x plus 1. Where there was the y, now we have that whole piece. And remember, the point was to get x by itself. So to get x on the same side. So now I add 2x. So 1x plus 2x is 3x plus 1 equals 16. Those cancel. Subtract 1. And we get 15 equals 3x. Divide by 3. And 5 equals x, which is what we already knew we were going to get. So we've got 5 equals x. So then I come up, grab an equation, and say, well, now I know what x is, so I substitute 5 in for x, and we solve for y. So I get negative 10 plus 16 equals y. So y equals positive 6, so my answer, 5, 6. Okay, so there's what it looks like with substitution. There's what it looks like with graphing. Now the last one is elimination. So once again, we've got y equals x plus 1 and y equals negative 2x plus 16, which, if I wanted to, I could leave it like that. But this mentioned putting it in standard form, so let's just do that. So if I add 2x, I'd get 2x plus y equals 16. If I subtracted an x, I'd get negative x plus y equals 1. So then I make them, line them up, right? And I say, okay, do we have a coefficient that's the same? Yeah, the y's. It's both having 1. So they're both positive 1s, which means we're going to subtract our numbers. I'll put 1s in there. So we go 2 minus negative 1, which is really like plus, so that gives us 3. So we've got positive 3x. 1 minus 1, not negative 1, would be 0. So 0y equals 16 minus 1, which is 15. Now, sometimes it's good to take those coefficients, like 2 and negative 1, write it out here, because sometimes we can make mistakes doing it this way. So it's a good idea to simplify it that way. So 0y is just 0, so 3x plus 0. Adding 0 does nothing, so we just get 3x equals 15 divided by 3. And once again, x equals 5, which is what we expected to happen. Then take any one of these other equations, and we'll plug it in right here. Negative 5 plus y equals 1. Add 5 to both sides, and we get y equals 6. So once again, our answer, 5, 6. So there we go. That's the main gist of the project. So we used elimination to solve our system. We used substitution to solve our system. We used graphing to solve our system. And we used tables and formulas to help us arrive at that once we had our sequences. So now that we've got our sequences, you do the work to figure out the formulas that help you figure out where they intersect. And there we go. Good luck on your own project. Once again, make sure you're not using my numbers, or else that is completely wrong. Pick from those other options and use those ones instead.